Nowadays, you can get data from everywhere. You can buy products, you can sell products, you can check your bank account, you can work from home. Like here, I can control the whole antenna, the whole system from home. I can check all of the parameters here. I can do anything from home, and everything works within a browser. And therefore, we have to create such pages if we want to support such possibilities. And a very, very important language in this scenery is HTML. And HTML is a markup language. And markup language is directly connected to the language theory. And markup just represents that you tag everything with special markups. And there are others, like markup languages, which are used to represent data files. And therefore, we will talk about XML and HTML in the daily use. And in the next lesson, we'll have a look into these special format descriptions. So please follow. Welcome again, this time to the lesson about markup languages. You daily use markup languages. If you use a mobile phone and you open a web page with a browser, then you use markup languages. Therefore, they are really essential. So we will have a look into two. The one is XML and the other is HTML. So today we want to look into the following items. First of all, I want to explain to you why markup languages are so essential. So on the way to the markup language, we will have a look again into the binary formats, into the ASCII formats, and what is the special thing of these markup languages. Then we'll have a look into a special markup language, which is really essential because it's an explanation or a description of other languages. So with XML, you can define formats, and therefore formats are nothing more than explanations or descriptions of other languages. And how can you make this formal language really formal? So this means that you need a way to describe this formal language. Do you remember language theory? In the language theory, we had these graphs, or we had these rule sets. And therefore, you need a mechanism to really describe such a rule set. And this can be done with DDT or with XML scheme nowadays. But DDT is exactly what you know from your language theory lesson. And if you think about what you need for a markup language, then you will also come to the solution which language type, which class of languages or is used for this XML style. Then we want to talk a little bit about the disadvantages of this XML, and I will show you another and more famous, for the daily use, more famous language, which is called HTML, and which you use really daily in your browser, in your mobile phone. So therefore, let's directly go to the first item on the way to the markup language. So if you remember, we started with binary data formats. We started with an altimetry project in the tutorial, so you had to read this file, and the file looks really strange, if you open it with an editor, because each single character element, so each single 8-bit element, is converted with the ASCII table into a character. And therefore, you have the situation that you have to know the structure, the format of this file. And this means it's a really dense, a really small file, but it's not so nice, handleable or manageable. Therefore, you need a description. And the description is usually given by an additional representation or an additional file where you know which elements and with which size you have to use these elements. So in our case, we use this RAD, reduced altimeter data format, and this RAD file contained time, a latitude, longitude, and explains that the first is a double, the next is an integer, the next is an integer with 8 bytes, with 4 bytes, and so on. And therefore, if you have this file, you can read, or if you have this description, you can read this file. And the same is if you have other formats, you always have to know the format. But the nice thing with ASCII files is that you can open it with an editor and you can check what is the content. Here, you don't have the chance to check it because it's binary. And if you don't know this format, then it's a problem. So how to read the file? You read it with normal file methods. You open the file in a reading style, and then you read one double, for example, or one integer, or one short, or one unsigned short, and then you have this, and then you process these things. So therefore, if you open an int, then you read 4 bytes, so 4 character elements, and these 4 bytes are then combined to one special real value in binary style. Different to that is the use of ASCII. In ASCII, you also have a format. So if you save something in ASCII, you also have structures, like here a table, for example. You have a clear separation, like a tabulator or white spaces. You can have headlines, you can have rows, columns, or you can have also other text structures. So you structure things with spaces. So you need more space for that. So for example, here you have the situation that a floating point number is exactly given with a special precision. So 2.81, for example, has exactly 2 places after the floating point. And another thing is here that, for example, we have here this this German style, because if you watch this here, you have this comma. So the fraction is represented with a comma, and therefore you have to think about country specifics. With binary, you don't have to do that. So therefore, this is a disadvantage. Another disadvantage is that if you want to represent the whole precision, then you need a lot of space, because here it would have to represent 18, 19 places after the comma. So 18 characters plus the characters in front of the comma or the dot in the floating point style. So you need at least 20 or 30 characters to represent the whole number, where you have just, for example, 8 characters or 8 bytes in the binary representation. So there are the disadvantages of ASCII, but the advantage is a clear one, because this one is real nice. You directly see the structure. Nevertheless, if you don't have the information of the headlines here, then you also don't know what the numbers are. Therefore, a new format or a thing which deals with this stuff should also represent the format and the data in a way that a computer can automatically derive the structure and the internal, let's say, grammar. And therefore, on our way to the markup language, we convert this table style into something like this. You add a description or a description ID or a name, an equal sign, for example, and then the value. So this is the next step. So for example, detector ID, then segment length, then time, speed, and so on. So you have all of this stuff here, and you directly know this. You can also maybe add some commands, so that you add a mechanism that you can add some commands, but that's it then. So the next step is this. So even if you don't have this structure, you directly can derive the names of the different values from the format. So the next step, what is the next step? The next step on our way is that you restructure it with a mechanism that you don't have to think about, let's say, special delimiters, so tabulators or white spaces or things like that. In best case, you always start with a starting tag and with an ending tag. So therefore, let's have a look into the date. You have date begin, and in between date begin and date end, so you have these tags here, and in principle these are already the markups. So if you have this start and end block, so like in each computer language, you have this curly brace start, curly brace close in C, for example, or you have in MATLAB, you have special start and end criterion, so if and end, for example, things like that. So you create some blocks, and you can also make nested blocks then. So in between of this clear start and end tag, you have the information. It does not depend on how many white spaces or whatever you have inside here. You have the real value. Problem is that this real value here, or this value which you want to use, or this information which you want to use, is not really classified or characterized how it should look like. So there can be now a number, or there can be now a whatever. Therefore, for example, for a representation of a style, it is quite good, because then the content is not necessary to be interpreted. But for data, we have to think about how to represent these things. But the principle is clear. You always have a start and an end tag. So here, detector begin, detector end, and you can have a list of these things. So therefore, it's the next step. So remember, almost forgot. So which language is this? You have start text, you have end text, you can have nested ones, so that, for example, inside you can repeat the same tag again. If you have something like a computer language where you have this, let's say, nested structures, then you need a context-free language. So therefore, it was so necessary that you learn the theory behind these languages, because here nothing else is used like context-free interpreter, and therefore you have to do this. Okay, so what is the next step? In the next step, it's much better, instead of having such start and end things, that you use special notifications and block structures. So for example, instead of define start and end, you make something like this detector with this lower and greater sign, and then you end up with a slash or backslash, depends on what is used. So in this case, it's a slash. So but you have always a corresponding endpoint. The endpoint is this slash version, and the start point is the version without the corresponding part. Without the corresponding part, without the slash, of course, backslash or slash. Okay, so I'm sorry. You have always a corresponding part. So if you now look into this, it's already really nice structured. What you also directly see is that you extend a lot of additional information. You extend a lot of text in addition to identify and to clearly describe the things. So for example, you have detector ID, therefore you really easily find this, and you have also a path through this graph or through this format, because it's like a graph. You start with observation, then you have date, then you have detector. Detector contains again with detector ID, and so on. So therefore, it's a clear structure, but you add a lot of meta information, a lot of describing information, and therefore, starting from the binary file with where we had 8 bytes, and one additional file which described this complete set, 8 bytes for a number, you have here now a complete line, for example. And therefore it's the problem that with ASCII and with this XML, it really extends the size. Nevertheless, it's a really nice tool to represent these things, and you can also extend this just start and end situation with additional information. So for example, you can describe the unit of a value, or you can describe other additional meta or real meta information which you use for the processing of the data. And therefore you can have attributes. These attributes can be extended. For example, observation can have the location, the date of the observation, can have additional segment length. You can mix this so that you not always have to use this style. You can also extend special attributes. For example, the units of values, or you can also describe maybe the structure of the value or the content, if it is a number, an integer, or whatever. It doesn't help you too much in this case because you have to write the complete number completely in ASCII, but to interpret and to process data, you can add additional information. So, and if you look to this, then you already have the markups and you already have XML. So XML is very intuitive because XML does not define predefined or reserved words. It just defines the structure, how it should look like. For example, it defines that you have to start and you have to end with a corresponding tag, that you can use attributes, things like that. But what it does not define at the moment is that, for example, a date, a time should look like this, a date should look like this. So therefore, you need additional descriptions, you need additional information to describe this if you want to really check everything, but it's really intuitive. So you can name it as you want. You just have to follow special structure. And therefore, XML, for example, markup languages are in general just a description of something else, of data, of styles, of anything you can imagine. So what you have is a possibility to individually, as I said, describe in a very human readable way data, or in principle the format of data. You describe with your language the language of the format of the data, and it's, as I said, very intuitive because it just defines the structure to describe the things. So if you look into this, then what is a markup language? What is the markup style? What is the principle behind? You have markups. Markups are these tags. You can individually name this. So you have keywords which enclose information. You have a starting tag, you have an end tag. So these two tags surround the information. Then you have the possibility to add special types if you are able to describe how this type should look like or how the structure should look like. You have additional types which you can add. You can add additional meta information, not only meta information about the format, also meta information about the real data, for example, the unit or the date and things like that. And you can interact between the markups. So for example, you can set links, or you can also get nested sets, like you can compare it like or you can compare it to an if-else construction, where you can have if and then another nested if and a nested if and so on. So this is the general principle, and this is also a context free language. So this context-free style is again very essential here, and it's standardized. So the essential part is that you have to do a standardization. So with this, we now know in principle what a markup language is, and it would be possible to stop now because you're now able in a very simple way to describe data. You just sit down, you create your own names, your name classes or whatever. You make these greater and smaller signs around. You always make a start tag and an end tag. And then you fill the data which you want inside of these tags. You add additional attributes. Finish. The markup is prepared. So that you don't do anything you want, they are standards. And we want to go now to this standard, the extended markup language. Markup languages have a long history. So they're as old as the internet, almost, because the first markup language which was created was HTML. It was a description in the 1989, where you were able to describe the style in a very simple way to make things bold, underscored, or underlined, or in a special color, so that a standardized software utility, first of all, can represent this like a browser, and that you can also connect these documents so that you can make links to other documents. And therefore, this is one very essential part, that you have a description language of the style. In the 1996, XML also started. It was a mixture of different other things, but nowadays is a very essential part. Even the Word documents are XML style, and a lot of standards were created. For example, standards to describe the XML files or the formats with XML scheme, or that you make some queries which are often used nowadays in XML databases, things like that. So it's a very interesting thing. That's a long history, and that XML is in principle nothing more than a language which describes languages or formats representing individual information. It's a language for physical representation of electronic data exchange. So it's really focused on the electronic representation of data, and it specifies a syntax with additional documents. Remember the binary format. The binary format had an additional description. Here you can also have an additional description which checks if the format is correct. So in the early days, DTD, data type definitions, were used. It's a very simple representation of these rule sets which you learned in the language theory. Or nowadays everything is based on XML schema definition, which is this XSD. We will focus on DTD here because XML schema, so the whole XML suite is really big and would blow this lesson here, but we want to focus on the main things so that you understand the principles. So this XML is a common standard, standardized by the W3C, so the World Wide Web Consortium, and their methods for the character encoding, so that you don't have to think about special country codes. You have escape sequences and syntactical definitions, so that everything can be parsed automatically by utilities. Therefore, a lot of libraries are now available to be integrated in your software to read the data in XML. So MATLAB can directly read XML files, things like that. So there are a lot of existing tools for the generic parsing, or the manipulating, the converting, the transforming, the reading, the use of the data in documents. And the structure of an XML document is exactly what we had before. You have these tags, you have these markups, you have these start and end tags, you have this additional information, and you have also a possibility with additional information, so that you can give special tools or libraries and information which standard you use at the moment, for example, which version of XML you use, and if you have also lists of other tags, so that you have sequences of tags or that you have also repeating information with corresponding start and end tags. So in principle, it's always a list. A block contains of a list, or a block contains of another block. What are the tag conventions? So what are the conventions to name these markups? The tags can be defined individually. This is the important thing here in XML. So the tags can be defined by the document designer. Tags must always start with a character or with an underscore. It's not allowed to start with a number. For better use, just the ASCII sign should be used, even if Unicode is allowed. For the data, it doesn't matter, but for these individual tags, it's always better if you just trust on ASCII or ANSI characters, in best case on ASCII characters, because then you don't have to work with country codes, and all of the programs, all of the different libraries can directly read it. The tags should be and are human readable. In best case, you really use human readable parts and not only very short acronyms like I, A, O, and so on. Write tags in lowercase and separate with following styles. You can write student minus first name minus name, or you can use also this camel case style. In best case, you always write in lowercase, because then you're completely independent. Indent tags should also be used according to this level of structure. So for example, if you have nested blocks, then you should always use this indent so that you have white spaces in front of this. So it's similar to a programming language, and in principle XML is a programming language for the description of a structure. And if there is no end tag, then there is a special style tag which contains, so if you just have, for example, a tag with an attribute, like here, light, status on or off, then there is no information between the start and the end tag. And here you can then use just a start tag where this slash is at the end of the start tag. So like here, light status equal on, and then you have this slash. This reduces a little bit the size of the format. So in principle, how does it look like? You have these additional attributes which provide additional meta information about the element. You have a lot of possibilities to separate with white spaces, where the white spaces are not interpreted in the format. It's like with HTML. And all rules or all tags follow the special XML rules. So how does XML structure look like? In principle, you have a syntax tree. In principle, it's nothing more than a tree, which is explained as a list of. So a sequence or a list of, which is again just a sequence of the same tag or of the same markup. So in our case, for example, if you want to represent the data which we saw before, you have the higher root element observation, and then you start with the tree. You have a list of detectors. So therefore you have a detector block and then a detector block, and each detector block contains observation records, and each observation record must be built by time, speed, smooth speed, traffic volume, and so on. So therefore you have a well-formed document. If all start and end tags are available, you have this ordered list. In principle, it's not necessary that it is ordered because you directly find it, because you can make a tag which has observation.detector.observationRecord.time, so that you have a clearly defined setup, and each start tag has a corresponding end tag, and between the tags there is text or a nested list of other tags. So this is a well-formed document, and all parsers, all tools can check directly with this description with a description of the XML if the XML document, the real XML document with the real values, so with the data, follows the structure. So a valid document is a well-formed document, so it follows the well-formed definitions and is conformed to an associated XML schema definition. So you have now an additional definition. You can have a well-formed document, so it follows all of the rules from XML, but there is no description about how the document should look like. If you have an additional definition, XML schema definition or DTD definition, where XML schema is much better because it describes more than that, then you have really a valid document, because then a browser or another tool or a library can automatically check the grammar and can check if everything is correct. It's like a parser or like a compiler in a normal computer language. Additionally, you can also have comments. Comments are this style. You have this greater and smaller sign, and then you have this comment in between this block. This exclamation mark represents comments, but also special data. So it's a characterization that something special happens. So comments have these two minuses here, so that comments are not allowed in tags and are ignored during the processing. So it's a real comment. So you have this, you can use this everywhere. It's just not allowed to have them in the tag name itself, but this exclamation mark can also represent data which should not be parsed. So comments are not parsed or not processed, and also data, for example, if you have a binary block or something like that, or if you have a block of XML-like structures in a data block, then you can also use this exclamation mark to avoid the processing. In addition, you have these brackets here, rectangular brackets, and C data, so that it tells everything what is in this block of C data is not parsed and will not be processed by an XML parser, by an XML tool. So XML also has some additional possibilities. For example, if you have the situation that different developers use the same names for the tags or for the markups, so then you would have the problem that you have different representations, and then that you have different, let's say, problems if you combine these different representations. It's similar like in MATLAB, if you have different scripts of different programmers and the programmers use sometimes the same names. Therefore, you can create namespaces. Namespaces in XML case are nothing more than an additional information which you add ahead to the markup name. So in this case, for example, TS, and you use a colon, and then this TS is the namespace, and this colon is the separator to the name then of the markup. So in principle, it's a prefix which you add to each additional, or which you additionally add to each markup, and you have to define the namespace with an additional URL which you add, so that it is a real clear identifier that this namespace is predefined by this URL. It's a domain web page which represents this part, so that it's really unique, and you have to have a description of the namespace there. So I walked quite fast through this XML description, because I think it's really simple. To create a well-formed XML file, it's quite simple. You just have to sit down and think about which parts do you need for representing your data. So for example, you classify, you give names about what is part of your content. So if you have a table and you have different types of the columns, then take the headlines and just tag it with this greater and smaller signs. Start with a start tag, end tag, and you have everything what you need. You can additionally add these attributes. Quite nice. The difficulty is if you want to write the description in a way that an automaton or a parser can understand and can interpret this, so that you have to use a valid formalized structure, and therefore you need a description of your XML file. It's not necessary, it's not only enough that you represent the data in XML, you also have to describe your XML format. And therefore, you have to learn a lot of more. And also to find the data, to search in the data, you have to learn a lot of more. So, therefore, we want to have a look into the simplest description mechanism, which is exactly comparable to what we know from the language theory, from these formal languages, from the description of, how would I say, regular expressions. Same styles, just for the use of context-free languages. So let's have a look into the description of XML documents, of the format of an XML document with DTD. If you think about what we used in our theory, then you should directly know what are the requirements for a definition of an XML document. If you go back to the language theory, we defined the alphabet, so allowed elements. We defined rules, so a sequence of what is allowed. So, and then we, in our case here, we have to define also data types because we want to represent data. So the same here for an XML document. We have to define the tags which are allowed. We have also to define which combinations, sequences, nested structures, optional or mandatory parts are in the document. So this is in principle the rule set. And in our case here, we have also to define additional information like the data types. In principle, we have two possibilities. Here we want to talk about the DTD because this is the simplest version of describing XML file. It's the simplest version because it's directly comparable to what we know from the language theory. XML schema definition is a little bit more complex because it uses XML to describe XML. So you use the same structure like in the format to describe the format. It's like pulling you out of the dirt by pulling on your hairs. So you take your hairs and you pull yourself out of the dirt. So it's something like that. You describe the format with the same format. Therefore, you have standardizations, you have reserved words and things like that then. So it's a little bit not so open anymore, but it is really nice. So for DTT, it is simple and easy. It's very comparable to regular expressions, but it's not so flexible. You cannot describe all of the data types, things like that, all of the structures, and it is not an XML syntax. So DTT must be interpreted by a different mechanism, while for XML schema definition, you can use the same XML interpreter. So it's XML schema is more complex. It's really a rigorous type definition setup. It uses the XML syntax as explained, and it is much better for the automatic processing conversion of XML documents. So let's go back how such a description of a language or of a format can look like. So if you remember, XML nested, so we have to use this context free style. Do you remember this? So XML looks like a mathematical expression. It's a formal mathematical expression. Therefore, you have this context-free language, you have this rule set, you have the definition of the allowed words, you have all of this stuff, and in combination with mechanisms which you know from the regular expressions, like the plus or the question mark. The plus means it matches one or more times. The asterisk, for example, means it matches 0 or more times. The question mark means it's a possible 1 or 0 times match, so that it is not necessarily to have this tag available, things like that. Or you can define how often it should match. So if you have this, the production rules and all of this, you can directly convert this in a description structure to describe a language, or to describe also a format, because a format is nothing more than a language. So if you understand this, then you know why I explain these mathematical formal languages. So it means you have to describe which element is part of another element, how the elements are combined as sequences, things like that, production rules. We have now to find a way to do this. So let's have a look into the definition here, which we had. So it's our own definition, it's our own setup, and this own setup uses our own namings, so observation, detector, and things like that. And you can convert it, like with ETF, into these grammar rules. So what do we have? We have a root tag, which is observation. Observation contains a detector sequence. Detector sequence means that we have detector, 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 detector. A detector itself, or a detector sequence, is a detector sequence and a detector. So this is the regular expression part here. So it's a detector sequence or a detector, or only a detector. So again, a sequence means you have a list of detectors, and then a detector contains of a list of detector information, so of records. So therefore you have the same for detector sequence, you have the same for detector like for detector sequence. So detector contains observation record sequence, and the observation record sequence contains the observation record sequence combined with an observation record or a single observation record, and so on. And then you can go down until you get the real data, which are the terminals. So these are non-terminals, and these are the terminals. You have data, and data are then the types or the data itself, and you have to describe this data with a special type. Okay, so you have this list and you have this data type. You have to do all of these things. Okay, so how can you convert now this description into DTD? So what is a DTD compared to such description? And here we use these principles which we used for regular expressions. So if you have a sequence, then you can use this plus or asterisk. If you have elements which are optional, then you can have this question mark and things like that. So let us convert our rule set here from the slide before into a rule set which uses this regular expression characters or specifiers. So for example, an observation now is a list of detectors. So detector plus. So we condense two rules here to one. And then a detector is a list of observation records. So observation records plus. And the observation records is a sequence of time, speed, smooth speed, and so on. And time is then data, and so on. And now you just need a representation. So this is one possibility, and another is used in DTD. So you take this representation which we created, and you just convert it in an equivalent representation which describes this. So each line is exactly one of these rule sets. So it starts with this lowercase or with this lower than sign and ends with a greater sign, has this exclamation mark, and then you have element. So this defines that now is a rule, and the rule says that observation is built by detectors plus, so a list of detectors. So inside of this parenthesis, you have the right part here of this rule, and the name of the rule, or the what is replaced by the right part here, is this one. So this is replaced by this, and then you have to create another one. So detector is replaced by observation record, again in this parenthesis. So it's exactly the same word you use here. You use here for the description, and this can be used now to check if the, let's say, XML is well formed and is also valid. Valid is a little bit, you have to use quotes here around, because with XML schema it's much better, because you directly can also define additional types and things like that. Here you just can say that it is a type, or you have special restrictions here. But nevertheless, it is used to describe the general format and how it is built. And therefore, this can be used by a parser, like a compiler, to check if an XML file really follows these rules. And this is a great thing. So what is the structure of this DDT in a formal way here? Let's have a look. DDT or DDTs are built by elements which describe valid tag names. And also they add the description of the content of the elements. Content descriptions are in principle really, let's say, limited in this style. As I said, XML schema really defines additional types. Here we can just have PC data, which is in principle anything of data. So you have this hashtag sign PC data. You can have any, so which is anything, or it can be empty. Content description can also be a combination of elements, so that other DDT lines are part of this of these combined elements, like a list, or like not a list, a sequence of different tags. A link to the DDT must be set in the XML file, so it points to an URL, or it points to a local file, which is also transferred if a browser opens the XML, for example, or another tool opens the XML file. So you say an additional line says that there is a doc type called observations with a system which is obsdtd. It is also possible to add this DDT directly. Instead of have a link to this external file, you can directly add it to the XML file. But then if there are changes, you always have to do updates there. And it's much better if you link it. So you can have directly this doc tab with this doc type classifiers you can directly have this in the XML file. Problem is that you cannot describe everything, or that it is just for general checks. So it's similar to a simple formal description of languages. And therefore it's just a very general principle. But it's so nice because it's directly comparable to what we know from our theory in languages. So we have now here a mechanism to represent data. It's quite simple. You define your tags again, start tag, end tag, you fill data in, or you fill a list of other tags in. You can define attributes as additional add-on in the tag names, so that you have, like in a function, you have additional handover arguments which you name equal, and then you write what you hand over. For example, unit kilometers per hour. And then you have, if you know this here, then you have a well-formed representation of data. With this, with DTT for example, you also give a general description of the rule set, and then you have a valid XML definition. So this means here you have a well-formed structure, and here you have a possibility to check if the structure, if the grammar is really syntactically correct or valid. So with this knowledge, we can directly also go to HTML. But before we do this, I want to talk just on one slide about the disadvantages of XML. So what are the disadvantages? If you think about that, you might directly come to some solutions. One is that the size of the file is really large. So the file size really grows if you want to have understandable markup names or tag names. And therefore, even if it is human readable, it is not really human readable. So you need again a parser. The problem with parsers is that not all parsers check everything, and that it is not possible to check really everything. So special checks are not always realized by parsers. Nevertheless, you also have to know the semantics. Remember the barking dog and the barking cat. So you have still to know if kilometers per hour is really a unit or something like that. So you have to know the semantics, and you have to add an additional checker like in a compiler where the semantical correctness is checked, as long as you can do it, of course. XML is in principle just a structured description language, which can be used very individually. So as you said, it's so intuitive because you can define your tag names. You can do anything what you want, or everything what you want, and therefore everybody defines own formats. So therefore you get a bench of formats which are again individual. So you have to write again additional, let's say, programs to understand these formats, or you make a standardization of the format again. And then you can think about why is XML so important if you have to do a standardization of the XML format which you define with XML again. The big advantage is that you have standardized tools which you can use, and that these tools can be integrated into your software. And another disadvantage is that the realizations do not allow unique and distinct things. So that even if you have XPath and things like that, there are always some, let's say, redundancies and things like that. Nevertheless, XML is a really essential language. And this essential language comes also from the, let's say, grandfather or grandmother of the language, HTML. And therefore, HTML is much more often used, and will be often used also by you, because the future in Internet of the Things, in controlling and working with all of this mobile data, will still have to present the data. Like in the intro, our monitoring system converts everything to a browser-based thing. So the background is still HTML, even if the output is produced by PHP or JavaScript, so that you have languages behind which produce HTML, or which place the HTML information or the data information on the right position in the HTML file. It is still a very essential part to describe the style of a data set or the style of a document with HTML. And therefore, we will have a very fast run through HTML. You will see a little bit more about that in the tutorial. So what is the difference between XML and HTML? In XML, you're freely open to do anything. It's just a carrier of data. So it's designed to describe the format of data. So the focus is on data. HTML is designed to display data, to describe the display, the view, the style of the presentation. So the focus is how data look like. And XML tags are therefore completely free, and HTML tags are predefined, so you have reserved words. So therefore, if you want to learn HTML, you have to really learn that, for example, a P starts a new block, or that B means bold style or whatever. So both are markup languages. So therefore, XML is in principle more than HTML. XML is in principle HTML, or HTML is a subset of XML. So the new X style of HTML really follows this. So it's a real XML representation. So nevertheless, the old style HTML is still in use. Therefore, if you understand XML, you really understand also HTML. You just have to learn the reserved words. And again, there's a quite nice tool on the internet. You can use this W3 Schools page again, where you can directly enter some HTML tags, and where you can directly check, for example, how the look in a browser, or how this output in a browser looks like. Okay? So therefore, you can test all of these things, and we'll do this in the tutorial as well. So how does an HTML code look like? Remember, it's a subset of XML, so therefore the structure will be very similar. So you have additional definitions for the interpretation, so for the program. In this case, you can set a doc type, you can also set the version and things like that. And then the important thing is that here you have a starting tag and you have an ending tag. Again, the only difference is that these tags are now reserved words. So these tags are now, or these tags must be exactly in this style. So it must start with HTML. And then you have a sequence of head and body. Head describes additional information about the web page or about the document, and body contains really the document. And then it's always the same. You have something like title and tag title. Or you have something like H1 headline 1 and end tag headline 1. So that you have always the same structure. And your browser or your compiler or your interpreter reads this and does a special behavior according to these definitions. You can add additional style sheets and things like that, so that you overload the standard behavior here. That you overload the standard behavior of the H1, for example, or the title or whatever, with own style. So with own color, with own font size, with own output bold or whatever. So with own style information. But if you don't do this, there is a standard representation which the browser uses if you have this style. And it's always the same. You have HTML, head and body. Okay? So in a detailed representation is like this. You can create web pages from a script which is called by web servers, or you have a static web page, and you can add additional so-called MIME types which must define what is returned. In this case, if you have HTML here, then it's a real HTML file. You can also set special UTF codes so that you're not fixed to ASCII. you can define a type plain text or image, so that the browser knows how the following processing will be done. So if you create a web page with or a dynamic web page with a script, you have to define additionally this MIME type. Then you have the declaration of the document. So for example, HTML5 or whatever, it's an older document. You have to define the version, and therefore the browser can do additional things with this version. Then you have a root element, which is in this case HTML. You have a meta information block, head, and you have the page content block, body. The meta information is invisible. The body block is visible or contains the visible parts. For example, the head information is not directly, or the title in the head information is not directly visible in the page. It tells the browser that in the window headline there should be an additional title. In the headline in the body part is really visible in the web page. So H1 to H6, for example, are headlines, which is large size to very small size. And even if you don't define own individual style sheets, you will have the standard style, which directly represents H1 in large size and H6 in small size. So even if you don't do anything, you can have a really standardized, nice presentation. And then, for example, P is a paragraph or block part. So it separates block of text so that you have different sizes between the block and things like that. So the difficulty now is that, for example, you have to learn all of these reserved words. So the next slides are not so dramatically, but or not so dramatical, but they are just a representation of the most important things. So I hope it's not too boring, but you will see in the tutorial that it's really easy. An additional information is that HTML is not case sensitive. So it's case insensitive. It doesn't matter if you write HTML in uppercase or lowercase. There is one, let's say, hidden standard which tells that the text should be in uppercase and the rest can be in any case you want. So let's have the first HTML code. If you fill, for example, the body with the following things, then you will see different blocks or paragraphs. And it doesn't matter if you have several of white spaces or if you have even new lines. So it's completely independent, because each white space, and it doesn't matter which one, is interpreted as one single white space. So the result of this and this and this will always be the same output. If you really want a new line here, so that also the output in the document should be with a new line, then you have to tell the interpreter that there should be that there must be a new line, and therefore you have to use this break or BR symbol. So otherwise it will be continuous flowing text. So each white space is represented, and it doesn't matter if it is a new line or a tabulator or a single blank symbol, is like it is one continuous text. Therefore you can structure your description of the style or your style of the document in the HTML file in a way that it is really nice for the editor, but the browser will convert it automatically. So if you have more space, then it will extend the block size. If you have less space, it will shrink the block size. Okay. Nevertheless, it will do it automatically. So HTML is used for browsing in the internet, so it connects everything with links. This is the essential part, that information is connected, is related to each other, that you have these links available, and therefore it's quite important that you can create web links. Web links are referenced with this href. This means you start with an A and you end with an A here, in between the A start tag and end tag, you have the name which you see. Where is it here? You have the name which you see in your document, and the attribute here describes the link where it goes to. So again, like in XML, you have information which is shown in the document, and you have attributes which describe this information or which add additional things to this information. In this case, it adds the real link. So if you push the button or if you push onto this link, it will jump to this web page. And you have a start tag and an end tag again. You can also have embedded images. For example, it's like a link, same structure like here. And in an image, it depends on. You can have a image, or it is different to the link, that you don't have this information. And here's, for example, in my opinion, there's a small break, because you can have an image altered text. So if the image cannot be shown, then an alternative text can be represented. Why is it not made like this? So that you have an image start tag and an end tag, and this alternative text is shown, it's present here. But it's like it is in the standard. So in the image, you have no end tag. And if you have no end tag, you can use it in the XML style version. You can have this backslash here. This is the new version of HTML. So therefore, you should do this. Or in this classic version, you don't have to use this, because the browser just uses this standard way. So the image has 3 different attributes. The one is the source of the image, is a link again, so similar to that. Then the alternative text, and then you can do additional things. So there are a lot of additional things. You have to check internet pages like this, which additional things you can do. In this case, you can define the width and the heights of this image, so the dimensions. You can also create a button on your web page. The button is this button, click me, button end. What the button does must be represented in an additional way with a formula. I don't explain it here, but just that you see, you even have interactive mechanisms. The interactivity here in the button is that the browser has to send information to the server. And this is the difficulty. Therefore, you need an additional thing like a format or a formula around, which pushes then the information. Because this is just getting information, and this pushes the information. If it just opens a new web page, it's just following a link, for example. So what else do we have? Very important are bullet lists. So therefore, you can have a bullet list or a numbered list. So lists, you see, very short tags, and this is what you have to learn. You have UL, which is an unnumbered list, and you have always LI, which is then the list element, starting end tag. So this is the list, and you will get bullets here, and here you will get an automatic numbered list. You can also mix this. So if, for example, if you have here in the list, in this section here, starting from LI to end LI, if you have here the complete block of a bullet list, then you will have a first indent sequence, and in the next indent sequence you will have the next list sequence. Okay, so that you can have some real, let's say, paragraphed lists. It's really simple. It adds with descriptions additional style information. Another thing is a horizontal line, or you can have additional, let's say, styles. So with styles is now, I cannot explain everything according to styles and things like that, because it's a large field. So you should just get in contact with HTML here. So you should just get the basics of HTML. So I just want to show you how inline style works. Usually you have an additional file like DDT in XML, so that you have an additional file. You can also have inline style, so you can have a style block, or you can directly define the style of the following part here. So in this case, I define a style which is for the body, and you write the attribute style equal, and in this quotes, in these double quotes, then you define a pair of properties and values. So in this case, the property name, and these are again reserved words. So this is the difficulty for a beginner to directly know everything what is possible. So you have to use a book or the online references to find out what is possible. So in this case, I use background color. Background color is the attribute name. So this is the first part of this definition pair. So of this property pair, and the next one is then the value of this attribute or of this let's say property. Sorry, this is the attribute and this is the property. You can compare this to MATLAB, where you also define special styles with a pair of a name and the value, so that you have the possibility to also change the order here. It just must be that you have the key in principle of the property and the value. In this case, I define the background color with red, green, blue colors. Remember the lesson about red, green, blue? This is the binary representation, always 256 elements, 256 from 0 to 255, red, green, and blue. You can also define the align style. For example, here the text align for the whole document, for the whole body here. Document is here centered, so that everything is centered. And then for H1, for example, you can also define an additional style which breaks this. So if you have an additional style which defines the background color, for example, it will be different because it will always be valid for this part here, what you define here. And then if you jump out here at the H1 here, then the general definitions will work again. So in this case, I define the color of the font, so which is blue, and then hello world will be blue, and so on. The rest will be red, and I can define the font size, things like that. All of these parts here are styles, and usually you do it in one block directly in the front of the HTML, or much better in a separate style sheet, so that you have this cascading style sheet definition in a separate style sheet file, which is loaded when the browser opens the page. And then you can use this style for different web pages. If you remember, or if you check usual web pages, you have one title bar, you have the menu bar, and then you have a lot of web pages in the background which are dynamically created, and you can use one central style sheet which is used for the whole document, so that all documents look similar. And that if you change it in one position, so if you do your content management and you change it in one position, the whole style will be changed everywhere. Okay, so therefore you can define your own very specific style. The font size is the everything. You have to learn this if you want to become a programmer of HTML pages. If you don't do this, you use the standard style, and the standard style is defined by the browser. Okay. Here is another list of important tags. So this list of important tags is, for example, that you can make underlined, bold style, important text, italic, emphasized text, marked text, small text, deleted text, inserted text, subscribed text, and so on. So you can have these things. Usually, in most cases, you use underline and bold text, sometimes italic, things like that. And remember, XML, same style of comments. If you want to describe additional things in the comments, or if you want to hide things in your web page, you can do it with a comment. The comments are not printed in the web page, but they will be in the editor version of your description. Okay, so comments are not interpreted by the browser. You can also create tables. I know that I run quite fast through these definitions. It's not the applied version of the course, because the tutorial will then go a little bit deeper into these things. So, but I want to show you the main parts which you should have heard about. So you can create tables, and in detail you have always to check the references. Okay. Table starts from table to end table here. You can define the style again. For example, that the table should be 100% of the complete page. If you say 20%, then you have just 20% of the complete page. And then you start with the lines of the table. So each line is TR, and each line contains columns. So TD or TH are columns. TH are the headlines of the columns, and TD are the normal elements in the column. So therefore you have a list of lines, and each line contains a column. And the browser automatically creates the largest size of columns. So for example, if you add here one additional column, then the complete table will be bigger, with a difference that, for example, if you have lines around your element, so if you want to make frames or borders around, then it can happen that the borders are not here if there is no information left. If you have empty information, you can use this NBSP semicolon, so that if no information is here, so empty element, then you can use this NBSP semicolon as an entry, which is not represented, it's something like a white space or backspace. So tables are really nice. So you have a real nice structure. Difficulties if you have large tables and if you have to follow the complete size, the complete structure all the time, and if you mix things here. So therefore indents are really, really important here, and also maybe comments. Whoops, I was too fast. So this is the last slide, you saw it. This is the last slide. So other important tags are, for example, inline frames. If you want a page or a document where another document is inline to that, it's like an image, you can have an iframe, and this iframe points to a source, and this source will be printed as part of the web page. And you can define a height and a width so that you can have a web page in a web page with scroll bars or not, and things like that, so that you have an inline web page in a frame. This is in most cases used if you have these framed outputs, like with menu bar and headline bar and things like that, or in dynamic adaptations, because you can load with scripts new web pages into these iframes. And these iframes are also were in most cases the critical parts, because if hidden iframes were used in blocks, then it was possible to start here with this link also foreign programs which could destroy or which could bring computer viruses. Therefore, if you, for example, use a block where external people can enter information, you should always check if web pages are added, because for example, if they add iframes and another person opens it, it's like somebody really requests this web page. So you even don't have to push a button, it's automatically, a browser automatically requests this web page, because the browser tries to present this web page as an inline web page in your web page. And if you have a block where you can enter text and you enter an iframe, an invisible iframe, and you link to a virus, then you can send viruses around. And therefore, professional blocks or professional formulars will always check if HTML is entered. And therefore, things are avoided. Like in YouTube, you cannot use HTML tags in the comments or in things like that. So this automatically prevents the situation that there are iframes available. You can also redirect. So in the head part, you can create a meta block. The meta block can be used to refresh or to point to another redirected web page. So if you call this web page, then it automatically points after a special time. So this content 0 means directly without a waiting time. it directly refreshes the whole web page with this link here. So if you open the web page where this is in, it will directly redirect to this web page. So these meta informations are also a huge bench of possibilities. It can also be used to refresh, for example, each 5 seconds, so that dynamic effect starts. The problem is that the different browsers use different wind blinds, so that, for example, you have a flickering effect. If a new web page is called, then you have a short white effect, and then the new web page is presented. So if you do it with this style, you will always have this flickering effect. For example, in Safari, in Microsoft Edge, in Firefox, in Chrome. The only one who does not do this is, which does not do this, is Firefox. But nevertheless, it's a simple method to update the web page regularly and to get a dynamical behavior. For example, if you want to send out information from a small Internet of the Things hardware, and which is connected to the network and which has a web server on it, and if you always get, for example, temperature, humidity, pressure things from your room, you can directly send a refreshing web page by just entering this into your existing document, and then the browser automatically does the refresh. So there are a lot of more things I can tell you about HTML. HTML is really essential because it's so easy to represent and to create documents. You can represent them in the browser for the whole world, for the internet community, and this is really nice because, for example, we always use it for the representation of the different, let's say, machines or machine states and alarms, so that, for example, if I'm mobile and if I use my mobile phone, I can check the status of the antenna, and the background is nothing more than a web page which is created with HTML and which is dynamically updated, in our case with JavaScript, but the background is just HTML. So therefore, stay healthy, stay safe. Let's drink. Stay safe, and we will see each other, I guess, in the tutorial about creation of web pages and maybe doing a little bit of XML. So see you next time. Bye bye.